Right, okay, good morning grade 12s. I'm going to just give a little bit of detail behind this exponential log function relationship. So the first thing I want to just do is quickly go through some grade 11 revision, if I can call it that, and that is to do with the exponential function. So you will remember if f of x was a to the x and a was greater than 1, in other words, your base a was bigger than 1, then you would expect to get an increasing curve, because as x is going to get bigger, y is also going to get bigger. 2 to the 1, 2 squared is 4, 2 to the 5 is 32. So as x is getting bigger, y is getting bigger, which is really what describes an increasing function. If I were to plot this graph, then obviously the first thing I try and do is find the y-intercept. When x is 0, 2 to the 0 is 1, so that would be my first point, and then I would always try and get a second point to give me a fairly accurate sketch. So if I make x equal to 1, then y would be 2 to the 1, which is 2, and so that point would be a second point on my curve. As x is approaching negative infinity, then obviously I'm getting closer and closer to 0. So for example, if x is equal to minus 3, it would be 1 over 2 cubed, which is 1 over 8. And then if x was equal to minus 10, it would be 1 over 2 to the 10, which is obviously getting closer towards the x-axis. But it's never going to cross the x-axis because y can never ever get to a value of 0. And therefore the x-axis is the asymptote, so it's an approach to the x-axis, and that curve should look very familiar to you. Okay, now a couple of things. When we talk about transformations, there are a couple that you did in grade 9. We're going to focus now on the transformation, which is the reflection. Okay, so I'm just going to work on this piece of paper as if it was a board. Okay, so the reflections that we looked at in grade 9. Well, first of all, we reflected around the y-axis. And when we reflected around the y-axis, if you just think about it, if I just do a little sketch over here, if you have the point 1, 2 and you were to reflect over the y-axis, it would become minus 1, 2. So what actually happens is the x-coordinate changes sign. Okay, so if you reflect around the y-axis, then the x-coordinate changes sign. Okay, if I can just write it like that to keep it simple, and the y-coordinate stays the same. So algebraically, if I took this function y equals 2 to the x, okay, and I were to reflect it around the y-axis, then I'm going to do exactly what I've seen here. So the x value will become negative. So y equals 2 to the x will now become y equals 2 to the minus x. And if you wanted to take that a little bit further, it's 2 to the minus 1 to the x, and that will be a half to the x. Now that means that the base a is now between 0 and 1. Now you will recall in grade 11, if your base was between 0 and 1, as opposed to being bigger than 1, you got a decreasing function. Okay? And if you look graphically, if I take this graph, I'm just going to make a little red star there, and I were to draw that graph, then obviously it would still go through the point 1 if x is 0, and if x is now equal to 1, then y would be a half, and I would get this decreasing function. I'm going to just draw it in red to distinguish. Okay, and so we can quite clearly see that the red one is a reflection of the black one around the y-axis. So this is the graphical representation. This is the algebraic working. Okay, so y equals 2 to the x. I reflect around the y-axis. I replace x with minus x. That's the graph that I get, and that's what it looks like graphically. Okay, we also learned about a reflection around the x-axis. So if we think about it over here, if I just draw a little sketch, and if I have the point 1, 2 and I reflect over the x-axis, it becomes 1, minus 2. So what happens is that the y-coordinate negates, okay, changes sign, and the x-coordinate stays the same. So if I were now to reflect y equals 2 to the x, around the x-axis, the y becomes negative, the x stays the same, and therefore y equals negative 2 to the x. And you cannot put that in a bracket, okay? It's negative 2 to the x. So only this 2 to the x, the 2 is raised to the power of x. Now, that's what it would look like algebraically. What would it look like graphically? Well, all I would do graphically is I would say I started off with this function. I'm reflecting around the x-axis, all right? And so graphically, and I'll do this one in green. Okay, do it in blue. Green doesn't work. Oh. Okay, here we go. Right, so if I take my original function and I reflect around the x-axis, I'm going to see graphically, without even looking at this, that my reflection is going to look like that. Okay, reflecting the black one over the x-axis. And obviously I said that your y becomes minus y, so the 1 now becomes minus 1. Okay, the 1 comma 2 becomes 1 comma minus 2. So I can quite easily see from the graph, just by the reflection concept, that the graph of this must look like that. And if I were to go and make x equal to 0, 2 to the 0 is 1, so minus 1 would be the y-intercept. If I chose x equal to 1, I get the point 1 minus 2. Right, so these are the reflections around the y-axis and the x-axis. So it's just normal reflections. But we also learned another reflection in grade 9. And that reflection was around the line y equal to x. Okay, so I'm just going to take a pencil and I'm going to draw in the line y equal to x, which would look something like this. Okay, right. And now we have to say, well, what would happen algebraically? So if I started off with my function y equals 2 to the x, so I'm reflecting around this line, right? So my original function y equals 2 to the x. What do we do when we reflect around the line y equal to x? Well, we do exactly what it says. We say y becomes x and x becomes y. So the first thing I'm going to do is I'm going to say, well, my x replaces y becomes x, and this x becomes y, okay, if I'm reflecting. And then I want to write it in the y form. So you've learned how to go from exponential to log form. Why do I want to go to log form? Because I want to make y the subject, which means that in my log definition, I said that if x equals a to the n, then it implies that n equals log x to the base a. So the exponent is the log of this number to that base. The base here remains the base here. So the exponent will be the log of this to that base. Now that would be the reflection algebraically. And I got that by interchanging the x and the y. Okay? Now, if I go to my graph and I just think graphically, how would this look? Just on a pure graphical. Well, here's my y equals 2 to the x. Alright? And if I take this curve and I reflect it over the line y equal to x, right, I can see that that is going to go there. I'm just reflecting it directly over. Okay? The point 1, 2 will become the point 2, 1. Remember, we're interchanging x and y. This is the point 0, 1. It will now become 1, 0. This is 1, 2. It will become 2, 1. The x-axis was an asymptote. So now the y-axis, we're interchanging x and y, becomes an asymptote. So that means the graph is never going to cross the y-axis. And so I'm going to get a curve that looks like that. Now that is your log function, alright? And if you were to use your calculator even and make x equal to 1, then you would find that when x is 1, the log of 1 to any base is 0. So, and if you made x equal to 2, the log of 2 to the base 2 would be equal to 1. So if x was 2, y would be 1. But the important thing is that as soon as I have the exponential curve, okay, I will automatically be able to draw the inverse of that simply by swapping my coordinates, if I can call it that. But remember, it's not just swapping. It's because you're reflecting this exponential graph over the line y equal to x. And by doing that, it becomes the log graph. Okay? Yeah, so that's the relationship between your exponential and your log graph. These other curves are simply reflections over this one, the y-axis, the blue one over the x-axis. You can now take any curve and you can reflect over the y or x-axis or reflecting around the line y equal to x. Just remember, if you're reflecting over the y-axis, you're replacing your x with negative x, okay, because obviously you are changing the sign of x, you're keeping y the same. If you're reflecting over the x-axis, your y negates, your x stays the same. And if you're reflecting over the line y equal to x, it becomes a whole new function, okay? You interchange your x and y, and you then rewrite it in the y form using your log definition. So that now becomes your log function. That's where your log function comes from. Okay? Just one more little thing. If you had the negative exponential, say the decreasing function, the red one, all right, and you had your line y equal to x, this is just a very rough sketch. So this was your decreasing exponential. If you take this curve and you reflect it over the line y equal to x, you would actually get that curve, because this would still be 0, 1, all right, which would still become 1, 0. But remember, if we had the point 1, a half, then it would become a half, 1. And so you would find that you would then get a curve that looks like this, crossing the x-axis still at 1, and this would be the graph of log x to the base a half. So if this was y equals a half to the x, this is your decreasing exponential because your base is between 0 and 1. So your base remains between 0 and 1. Your decreasing exponential becomes your decreasing log function. All right? And you can see if I take this black curve and I reflect it over the line y equal to x, I swing it around, that's what it's going to become. Right, so hopefully that's a little bit of a sort of a grounding. If you were struggling a little bit with that and where all these curves are coming from, hopefully that gives you a little bit of a better grounding. Okay guys, I'm going to do the memo to the quiz now, and I'll also put that up under my name. Please work through that very carefully to make sure you are okay with that quiz now.